Hi guys, so this is the second series on Math SL differentiation. In this series we shall be tackling stationary and inflection points. The first video in this series shall focus on questions that require us to analyze the curve of f of x. And we shall be tackling in this video the three questions right there in front of you. And before we start, I would like you to copy this down, these three tables right there, because we shall refer to them extensively in this series. They compare or associate certain conditions of f of x with matching conditions in f dash of x. We shall discuss this in more details as the questions progress, but keep it for reference because I shall ask you to refer to it as we solve the questions. I shall begin question number 1 shortly. So question 1 came in paper 1, November 2003, question number 15. Kindly take a minute, pause the video, look the question through, and I shall begin the explanation shortly. So we are given the graph of y equals f of x, and we are required to sketch the derivative function. Before I start sketching, there is some analysis that I need to do. Take a look. So I'm going to begin with what is written in red. I have analyzed the function in terms of whether it is increasing or constant or decreasing. This is obviously visually easy to determine. In this part of the curve, as x increases, y increases. At this point in blue right there, y is constant. The tangent to the curve is a horizontal line, and we say that the function is constant. And then at this part, the function decreases, y decreases as x increases. Similarly, here we have another turning point, so the function is constant. And finally, in this last section of the graph, the function is increasing. So this is the first part of the analysis, and this is visually easy to determine. Next comes the part in blue. And that simply involves translating the red expressions into associated expressions for f dash. And we use the table that I asked you to copy down in order to do this. You shall find in the table that when f is increasing, f dash is positive. So we know that for this portion of the graph, f dash is positive. Similarly, when f is constant, f dash is 0. When f is decreasing, f dash is negative. So this is easy to carry out for the rest of the curve. You simply translate our judgment on f into judgment on f dash. So now we know the state of f dash in every part of the curve, whether it's positive or 0 or negative. Finally, we begin the analysis in green, and this is also quite simple. There are two states of the curve. It is either smiling in simple terms or frowning. When it is smiling, I say that f double dash is positive, right there. This is a smiling face. So f double dash is positive. And in scientific terms, we call a smiling curve concave up. So this part of the curve is concave up because it looks like a smiling face, and f double dash is positive. For the left hand side of the curve is a frown. It's a frowning face, and hence we say that f double dash is negative. Finally, we select the key points of the curve, and we begin by the turning points, and these are obvious on the drawing in blue. The points where f dash is 0, where the curve turns from increasing to decreasing. This is for f. Or where f dash turns from positive to negative, or specifically when f dash is 0. This also applies to this blue point right there. These are the turning points of the curve. Next, we identify what we call the point of inflection, and this is the point that separates the frown from the smile, or vice versa. This is the part or the point where the curve changes concavity, and it is right there in green. At this point, roughly, this is not an exact measurement, but roughly this is the point on the graph where f double dash goes from negative to positive. It could also be the point where f double dash goes from positive to negative. And this is the definition of an inflection point. On the graph, an inflection point is a point where the curve changes concavity. In an equation, the inflection point is the point where f double dash changes sign. And this is an extremely important definition. And for f dash equals 0, this is the definition of the turning point. So the turning point is the point at which f dash equals 0. But you cannot say the inflection point is the point at which f double dash is 0, even though this is usually the case. The correct definition is an inflection point is the point where f double dash changes sign. Keep this in mind, write it down, it's extremely important. For the purpose of this question, we need now to translate our analysis into a sketch. So I'm sketching f dash, so I'm concerned with the blue analysis of the curve. I know that at x equals 0, f dash equals 0. Therefore, on the curve at x equals 0, right there, y is going to equal 0. Similarly, at x equals 4, right there, which you can find by counting these blocks, you have 4 blocks. So at x equals 4, again, f dash is 0. So I have another point right there for x equals 4 and y equals 0. These are called the x-intercepts of the graph. So the turning points of f are the x-intercepts of f dash, which is a way of saying that f dash is 0. Next, I find between the x-intercepts the state of f dash. Is it positive or negative? And I get that from my graph. I know that before the first turning point, right there, f is increasing and f dash is positive. So before this x-intercept, f dash shall be positive, above the x-axis. Then between the two turning points, so in this section right there, f dash is negative. So between my two turning points, which are there and there, we know that f dash in this region is negative. Right there, I'm going to be negative. And then after my second turning point, f dash is positive. So in this region, f dash will be positive. And f dash, as we said before here, is positive. So what does this look like? It looks like a parabola. And this makes sense because the curve of f is a cubic function. So we expect the curve of f dash to be quadratic. Take a look. So this is what the curve of f dash should look like. Take a minute, pause the video, copy this down if you will. I shall begin question 2 shortly. So question 2 came in paper 1, May 2010, time zone 2, question number 7. Kindly take a minute, pause the video, attempt to solve, and wait for the explanation shortly. So I am given a function in f, and I am asked a couple of questions about it, so it wouldn't hurt to begin by analyzing the curve of f. So take a look. So I have done what I've done before. I've begun my analysis with the red labels. You can easily determine where f is decreasing or constant or increasing. Next, I translated the red into blue. When f was decreasing, I assessed that f dash would be negative. When f was constant, I assessed that f dash would be 0, and so on and so forth. Finally, I identified the parts of the graph where f double dash is positive or negative. So for this first region right there, this is a smiling or concave upwards part, so f double dash is positive, followed by a frown, so f double dash is negative, followed by a smile, so f double dash is positive. And these changes of concavity are highlighted by my inflection points right there and right there. And I've also labeled in blue my turning points there and there and there. This wouldn't hurt to do anyway, and it will help us a lot with the questions to come. So let's read question A. Write down the x-intercepts of the graph of the derivative function given that the graph has a local maximum when x equals 0 and local minima when x equals negative 3 and x equals 2. Maxima and minima are the categories or the types of turning points. So they're simply telling us that the turning points are at x equals negative 3, and we already know this from the drawing, x equals 0, and x equals 2. And the minima are associated with the smiling parts of the curve, and the maximum is associated with the frown of the curve. So I want the x-intercepts of f dash. These are exactly the same as the turning points of f, because the x-intercepts are where f dash is 0. So where is f dash 0 on this curve? Here, here, and here. So these are the three values of x for which f dash is 0. Hence, the solution to question A is negative 3, 0, and 2. These are the points where f dash is 0. So for question B, we are required to write down all the values of x for which f dash is positive. And we've already done that by labeling the curve. Where is f dash positive in this curve? In this region right there and in this region right there. So I need to write inequalities that represent this region. So for the first region on the left, it begins at x equals negative 3 and ends at x equals 0. So I am looking for the region that lies in between these 2 points, but it does not include the 2 points because they are points where f dash is 0 and not positive. So I want this region, and this is the answer to it. So the first region is described by negative 3 less than x less than 0. As for the second region, which is right there, it is described as follows. 2 is less than x less than or equal to 3, simply because the function is defined only until 3. So for any value greater than 2 within the domain of the function, my f dash is positive. As for question C, it says at point D on the graph of f, the x coordinate is negative 0.5. So where is the x coordinate negative 0.5? Somewhere here. Explain why f double dash is less than 0 in this point or at this point. So I've already determined that f double dash is negative in this region. Why did I make that judgment? Because in this region the curve is frowning, it is concave downwards. Hence, they're telling me what I already know, that any point within this region, from this green point to that, has a negative value for f double dash. So how do I explain this? I simply state that the curve is downwards concave at this point. This concludes the answer to question number 2. Take a minute to pause the video, copy this down if you will. I shall begin the third and final question in this video shortly. So the third question that we shall tackle in this video came in paper 1, May 2006, question number 11. Kindly take a minute to pause the video, attempt to solve, and wait for the explanation shortly. So we are given the graph of f and we are required to analyze f dash and f double dash at some given points on the graph. So we begin by our general analysis of the curve. Take a look. So I've done my usual analysis for the curve. I've identified decreasing, constant and increasing parts of the graph in red. I translated them to negative, 0 and positive values of f dash in blue. And I've identified the regions of the curve for which f double dash is either positive or negative. And I've determined the points that separate the change in f dash in blue. So these 2 points mark the change in f dash. They are points at which f dash is 0, before them f dash is negative and then positive, or positive and then negative. Similarly, I've determined in green the point at which f double dash changes its sign, and this is what we call an inflection point. Once I've done that, it becomes very easy to actually solve this particular question, because all they require is to note whether f dash is positive, negative or 0 at the given points, and then whether f double dash is positive, negative or 0 at the given points. So basically we're just going to copy from the diagram. At A, is f dash positive or negative or 0? Obviously negative. And at B, f dash is 0. And at E, f dash is negative, right there. So this is the answer to question A. So these are the answers to question A right there in the table in front of you. Similarly, in question B, we are going to test f double dash at A and C and E. So at A belongs to the region for which f double dash is positive. So this is positive. C belongs to the same region for which f double dash is positive. How do I know that? Because both A and C lie before the green point, the inflection point. Anything before the inflection point is positive. It belongs to the smiling part of the curve. And anything after, including D and E, is negative. F double dash is negative. This is the region where the curve is concave down. Hence A and C belong to positive f double dash region, whereas E belongs to the region where f double dash is negative. This concludes our answer to question number 3. It also concludes this video. Take a minute to copy this down if you will. I hope you have found this video useful. Thank you.